is where we're going to start at. 10.3 is really not anything new as far as content. It is just putting everything we've learned together. It is going to be finding the area of composite figures. Formulas. Not till after spring break. It'll be the day we review for the Chapter 10 test. So you've got a lot of time to memorize those, and you won't learn any more new formulas. So there's 15 of them. You've got all of them. And it will not be the day we come back from spring break, but it'll be that Wednesday. So we come back on Monday. That Wednesday will be your formula quiz and review for the test. Okay? All right, so composite figures are just basically putting some shapes together. And I kind of mentioned this earlier when we first did 10.1. For example, I think I put on the board, correct me if I'm wrong, did I draw an ice cream cone in here? Okay, so if I have this ice cream cone, what two shapes could I divide it into? Okay, half a circle, which is called a semicircle, and a triangle, right? And so today that's basically what the lesson's going to be about in 10.3 is just they're going to give you a bunch of shapes and ask you to find the area of something that's not just one shape. So there's going to be different ways that they're going to look like, but one option is that you may have to divide it into two shapes that you know and then add those two shapes together. They're going to get a little bit more complicated than that, but that's the big idea. So a composite figure is just simply a figure that's made up of simple shapes like triangles, rectangles, trapezoids, circles. And the way you find the area of that composite shape is you find the area of each of those simple shapes and then use that area addition postulate to add those areas together. So we're just going to jump right in and look at some examples and work a few examples together and see if you're understanding kind of how to find this. So I want you to find the shaded area and round to the nearest tenth if necessary. What shapes do you see in this picture? Semicircle. Could divide it into a triangle. What else do we see? Trapezoid. So there's going to be a couple of different ways you can work your problems. The hardest part of this section is figuring out what shapes you have, where you have enough information to find the area. So Ruben said triangle, which means we could draw in this height and divide this into a triangle and a rectangle. And that might be the best way to work it. Or we might be able to just look at it as a trapezoid and find the area of the trapezoid and the area of the semicircle and add those together. Sometimes you're going to think this is the way I should divide my shape, but then you can't figure out the base or the height. And so you may have to go back and figure out a different way to divide your shape. So that's the hardest part. So let's see. Let's try using just two shapes, the trapezoid and the half a circle. All right, I'm going to call on you, so be ready. Let's go with Visai. What's the formula for area of a circle? Careful, it does have a pi and it does have a 2, but it's not 2 pi. Help him out, Brock. No, it does have a pi in it, so it's not just an r and a 2. Pi r squared, very good. Pi r squared, okay? So the area of a circle is pi r squared, but do we want the whole circle? Half of it. So be careful. Most of the time I'll see students make a mistake by only finding, because they found too much area. So we want half the area of a circle. So we're going to do pi r squared and then divide it by 2. Okay? Now be careful. That's not your formula for area of a circle, but we are dividing it by 2 because we only want half of it. And then we want to find the area of our trapezoid. What's the formula for area of a trapezoid? Let's go with Tate. Yep, it's plus. Be careful. That's our one that we easily confuse. So it's plus. Very good. When do we multiply in our formula that had a 1 and a 2? Diagonals. And what shapes is it 1/2 diagonal, 1 times diagonal 2? A rhombus and a kite. Okay? So again, just practice those formulas. Start memorizing those formulas. All right, so we're just going to find the areas if we have enough information here. So what is this 20 millimeters giving me in the picture? Diameter. And how do we find the radius for a half a circle? Divide by 2. So the diameter is 20. which means the radius is 10. So we're going to go over here and plug that in, and we have pi times 10 squared. And then we're going to divide that by 2 because we only want half of our circle. All right, we do not want to round until the very end, so I wouldn't grab my calculator and start typing things in unless you're just doing 10 squared. But what is 10 squared? 100. We don't need our calculator for that. So we have 100 pi, and then we're going to divide that by 2 because we only want half our circle. What's 100 divided by 2? 50. So I would leave it as 50 pi until we're ready to type it in for our final answer. That way we're not rounding in the middle of our problem. Is everybody okay with half the circle? Okay, moving on to the trapezoid. The trapezoid has 2 bases. What are the 2 bases in our picture? 32 and 20. Good. So we're going to plug in 1/2 of 20 plus 32, and we're going to multiply that by the height. What's the height of the trapezoid? 14. All right, what is 20 plus 32? 52. And what is half of 52 times 14? 26 times 14, which is? What is it? I'm sorry? 364. Somebody agree with Kirsten? All right. So now what do we want to do with this 50 pi and this 364 to get our final answer? Add them together. So we're going to take our calculator at that point, and we're going to type in 50 pi plus 364 because it did say to round to the nearest tenth. If it did not say to round, we would just leave it as that, 50 pi plus 364. But we're going to type it in and round. What do we get for our final area? To the nearest tenth. 521.1. Somebody agree with Ruben? All right, 521.1 units, millimeters squared because we're finding area. Don't forget to square your units, but only if you're finding area. Questions? All right, I want you to look at the next 2 at the bottom of your notes. So it says find the area of the shaded region, but it's kind of hard to tell what's shaded. So I want to make sure you're clear. On this one, everything's shaded. And then go to the next one. What's the part that's shaded on the next one? Just the circle part. So this is shaded over here, this is shaded here, and this is shaded down here and over here to the right. But not the part in the middle. So what would we do different on this one than what we're going to do on the one before? We would subtract. So we would find the area of the circle. And what shape do we have inside the circle? Trapezoid. And so we would find the area of the trapezoid, but we would do what between those values? Subtract them. Does everybody see the difference? So sometimes we're going to add, sometimes we're going to subtract. Okay, I'm going to give you about 5 minutes, and I want you and your partner to see if you can work these 2 problems. And then we'll come back and we'll check them together. So I'm just going to give you a little bit of time to please. It's okay if you're not done, but if you'll come up here, I'm going to go over this one first. I've seen a lot of good answers as I've come around. Area of the circle, be careful, is pi r squared, not divided by 2 because we're not looking for half a circle like the one before. If the diameter is 20, what did you get for the radius? 10. So you plug that in and you have pi times 10 squared, which is 100 pi. Again, that's not your answer, so I wouldn't round that answer. I would wait and subtract. We're going to take away the area of the trapezoid, which is 1/2 base 1 plus base 2 times the height. What were the 2 bases here? 12 and 20. And what was the height? 8. So we're going to have 1/2 of 12 plus 20 times 8, which gave us half of 32 times 8, which was 16 times 8. And help me out, what was 16 times 8? 128. So if we were not rounding, we would leave our answer as 100 pi minus 128. Remember that you treat pi like an x. You cannot subtract 128 from a number that has an x with it. You can't subtract 128 from a number that has a pi with it. So you would leave it like this, but it does say to round. So when we plug that in and round, you should have ended up with 186.2, is that correct? Centimeters squared. Questions on this first one? Okay, I saw less correct answers on the next one. Some of you just hadn't gotten to it yet, so let's look at it. What shapes do you see in this picture? Parallelogram and a triangle. That's probably what I would use. Notice these parallel marks. That means this shape right here has opposite sides parallel, which makes it a parallelogram. What's the formula for area of a parallelogram? Base times height. So we have base times height. Then we see the other shape in the picture that's left over is a triangle. Does everybody see now the parallelogram and the triangle? And again, that's the hardest part, is trying to decide how am I going to divide it. So just keep trying until you find a way that works. So now we need to find the area of the triangle. What's the formula for area of a triangle? 1/2 base times height. And what are we going to do with these two measurements? Add them, because we're finding the area of the entire shaded figure. So back to the parallelogram. What's the base of the parallelogram? 8. And what's the height? 5. Always that perpendicular distance between your two parallel bases. So we're going to have 8 times 5, which is 40. Then go to the triangle. What's the base? 10. What's the height? So we have 1/2 10 times 5, which is half of 50, which is 25. And 40 plus 25 is 65. Units would be feet squared. Questions, Dad? Of which one? The parallelogram or the triangle? The height is always the perpendicular distance to the base. So the base is 10, making that the height of 5. Does that make sense? And then the other shape is the parallelogram with a base of 8. And again, the perpendicular distance down to it is 5. Say it again. If you have a right triangle, but we don't have a right triangle here. When I look at this triangle, it's not a right triangle. Right triangles have 2 legs. Every other triangle just have sides. Okay. All right, flip your notes over to the back. And what you're going to see on the back is a word problem, which we're going to skip for right now, and then look at what's next after it. Do you see the next 2 graphs? On these, this is what we're going to lead into for the next section. And I'm going to have us do section 10.4 differently than what the book has us do. So I'm going to warn you right now that we're going to look at this a little bit differently, okay? But 10.3, first of all, says estimate the area of an irregular shape. If you want to estimate the area, you can sometimes just use composite figures. But instead, we're not going to try to change this into composite figures. We're just going to estimate by looking at that picture and counting the number of squares. We're going to get as close and as precise as possible. So think about this with me. If this is a 1 by 1 square, 1 by 1, what would the area of that square be? 1 square unit, right? Is everybody with me? So if we want to find the area of this shape, we could try to divide it into shapes that kind of look like them. Like, for example, this would kind of look like a triangle, right? We could do that, or we could just estimate. And to estimate, we could just simply count the number of squares we see inside our shape, and then multiply it by the area of each square. If it's a 1 by 1, we're just multiplying by 1, so it doesn't change its value. So we're going to estimate as precisely as we can, meaning we're going to use things like a half, a fourth, I'm not going to make you get super specific and say, well, that's 1/16. You don't have to get that crazy. But a half, a fourth, try to get at least down to about a fourth of your shape. So I want us all separately to count how many squares we think this is, and then we're going to compare and see what we come up with. Okay? Go. Write your final answer on what do you think the area of this would be? So about how many squares do you see in this picture? Raise your hand if you have an answer, not to tell me what it is, but just that you're done, you've had enough time. All right, let's go with Michael. How many squares do you think there are? 8. Anybody have a different answer besides 8? Dad? 8 1/4. So 8.25. Somebody different? 7.75. Somebody different? Okay, I got 8.5. So here's what I will do when I'm grading these estimation problems. I will give you 1 unit either direction of whatever the correct answer should be. So in other words, if the correct answer here should have been 7, let's say the correct answer should have been 8, I would accept a range of answers from 7 to 9. Anything lower than 7 would be too low. Anything greater than 9 would be too big. Does that make sense? So I got 8.5. When I looked at this, I said square 1, 2, 3, 4, and then I put these 2 halves together to get 5, these 2 halves to get 6, these 2 halves to get 7, and then this one I took off a part of this and made that a whole and called that 8 and said that that was about a half. So I said 8.5. So if that was the answer, I would accept a range from 7.5 to 9.5. Questions? Okay, most of the problems are not going to be this giant squares. So if you'll skip the next one and move on to your 10-4 notes. Look at your 10-4 notes. Okay, on the 10-4 notes, there's 2 parts to this. Again, this is where we're going to do it different than what the book says. We're just going to estimate. And to estimate means we're not going to try to divide it into composite figures and find their actual areas with formulas. We're just going to count the number of little squares that we see inside this shape. Okay, but notice now the squares have gotten much what? Smaller. So again, you're going to have to be very careful and pay close attention to detail, which means you may need to trace the picture in your book when you work the ones on your homework, or make sure that if you mark on your book that you go back and erase it. So I would be a very light marking if I did that, and then erase it really good when you're done. So we're all going to do the same thing here. You're going to work on yours. I'm going to work on mine. We're going to come back and compare answers. Again, I'm only going to give you 1 unit on either side of the correct answer. So you're going to have to be really precise. Go. All right, let's take some answers. Let's go. Andy, what did you get? 27.5. Oops, went too far. 27.5, a different answer. 28.5. 31. 30.5. Anybody have a different answer? 30. Anybody else? Okay, I'm going to show you method 1, which is what we are not doing. Method 1 would be dividing this shape into actual shapes where we have area formulas for them. That's the harder way. We are not doing that. So if you see that in the book, I'm not expecting you to do that. I'm expecting you to just simply count, which would be method 2, the number of squares that you see. Again, if you don't mark them in, color them in, number them, you're probably going to lose track of what you've colored in and what you haven't, and you have to be super precise. even including these little pieces like this into your total. So they say a good estimation would be 31. I got 32. I would only accept a range then of 30 to 32, one on either edge. So if you were the people that said, here, you are too low. You're going to have to be more precise in your answer. Okay, so a 30 to 32 is a good range of possible solutions. So notice one method I choose is to go through and number every little thing and then color in the little parts on the outside and show where I'm adding those to be really precise. You're trying to go to at least a fourth every time. Questions on estimation? Okay, so in the book, in 10.3 and in 10.4, we are just estimating if it's on a grid. Is everybody clear? That you do not have to divide it into composite shapes. You can just estimate if it's on a grid. Only if it's on a grid. Okay? All right, last thing for today are the problems where we're going to take it to the coordinate plane and try to find the area. But this is going to require you to remember some formulas from way back first semester. So they're here in your notes. You may have to use your distance formula. So here it is in case you've forgotten it. We sing a song to it. We should all know our distance formula. You may have to use slope. Here's your slope formula. Also remember slope is just what over what? Rise over run. So if it's on the graph, you can count to find your slope as well. Then other formulas you may have to use today would be Pythagorean theorem. What's our Pythagorean theorem? All right. So a squared plus b squared equals c squared. So these are some formulas you may have to use today to figure out the answers. There should be two more questions. Correct me if I'm wrong. There's one on the front. Flip it over. One on the back. Okay. We're going to end the lesson with doing these two examples. Everybody needs a piece of graph paper, and we're going to shift to the graph. Reese, will you bring me one too? Thanks, man. Thank you. Okay, guys, as soon as you have your graph paper, we are looking at the example on the front of your notes. We are graphing that example. So we're graphing the EFGH shape, okay? Take a few minutes, graph that on your graph paper. Make sure you're being really careful with your positives and your negatives and that you're graphing your shape correctly. Look at the board, make sure yours looks like mine or that I didn't make a mistake. Okay, is everybody good? Right, what did the directions ask us to do? Okay, read the very first sentence. You skipped part of it. Draw and classify the polygon. What do they mean by classify? What shape it is. So we're going to have to figure out what kind of shape this is so that then we can find the perimeter and area of the polygon. So draw and classify. This goes back to what we did a long time ago. To classify our polygon, we have to decide, is it a parallelogram family, like a rhombus, rectangle, square? parallelogram? Or is it a trapezoid family, like a trapezoid or isosceles trapezoid? Or is it a kite family, where it's not a trapezoid or a parallelogram? So what would we need to figure out before we could decide what shape this is? Say it again. Are the sides parallel? Because remember that if the sides are parallel, both pairs, that makes it what shape? Parallelogram. If only one pair of sides is parallel, what shape is it? Trapezoid. And if no sides are parallel, it is a kite. Okay? So let's start by trying to figure out if the sides are parallel. What would I need to know about them to know if they're parallel? Rise over run. I need to find their slopes. And if their slopes are the same, that makes the lines parallel. So let's start by finding the slope of HE. And again, you can just count since it's on the graph. What's the rise? What's the run? 2. 2 over 3. So 2/3. So then compare that to the opposite side. What's the slope of GF? 2, 3. So 2/3. So we do have for sure one pair parallel. Go to the other pair of sides. H to G. What's the slope of HG? The slope from H to G. Negative 1/3. We're going to go down 1, right 3. So that's a negative 1/3. What's the slope of EF? Is it also negative 1/3? Down 1, right 3. So that means we have both pairs of opposite sides parallel. So this could be a what? Parallelogram. It's definitely a parallelogram, which means it might be a rhombus, a rectangle, or a square, or it might just be a parallelogram. If it's a parallelogram, which we know it is, what's the formula for a parallelogram? Base times height. If it's a rhombus, it could still have the same formula, right? If it's a rectangle, it would have the same formula for area. But if it's a square, then all the sides would be the same and we would do side squared. Does this look like it's a square? No. Would we all agree we could rule out square? Okay. Does it look like a rectangle? No. And we know for sure it's not a rectangle because what would have to be true about these two sides where they meet? Right angle. And if the two sides form a right angle, that means they're perpendicular. What would have to be true about their slopes if they're perpendicular? They would have to be opposite reciprocal slopes. Is 2/3 the opposite reciprocal of negative 1/3? No. So it's not a rectangle. It's not a square. It might be a rhombus. If it's a rhombus, what has to be true about all of their sides? Congruent. Do you think that if I go up 2, right 3, that that's going to result in the same length as going down 1, right 3? No. Would you guys agree that we could probably say this is not a rhombus? Okay. So what would this be then? Just a parallelogram. So part A said classify. So we would put parallelogram. Now, if you're not sure, you'll need to find those side links to be sure. But we're confident by our measurements here that we feel like it's a parallelogram. Okay, then they want us to find the perimeter and the area. We already know that one way to find the area would be base times height. This is the part that gets hard and you have to be careful and applies to what we've learned today. I could find this base by doing distance formula or Pythagorean theorem. But if I find this base, do I know the height? No, because I need the distance that would be perpendicular to the base, which would be this, and I don't really know for sure where that's supposed to land. So on these problems, they're going to get a little bit harder. You're not going to be able to just look at them and find their measurements. You're going to have to divide them into shapes you can find the measurements for. So on this first example, would you agree that I could draw a line connecting E to G? Since that's vertical, what shapes does that divide this parallelogram into? 2 triangles. If I call this my base, look at your shapes. If I call this my base, could I find my height then? Yeah, much easier, right? So I'm going to zoom that in so you can see that. So if EG is my base, then my height would go from H straight down perpendicular, right? And those would be easy to find. What's the length of this height? 3. And what's the length of this base, GE? 3. And then if I turn it the other way, the base here is 3. What would be the height from F down? Oops. Get that where you can see it better. What would be the height from F down? 3. 1, 2, 3. Does everybody see how we can split that into 2 triangles and then find the base and the height? All right. So sometimes you're not going to be able to use the formula that they've given you or that you know. You're going to have to divide your shape into shapes you can find the measurements for. Because I can't find the height to a base of the parallelogram, but I can find the height to the base of a triangle. So we're going to divide this into 2 triangles and calculate the areas. Okay, so what's my formula for area of a triangle? Excuse me? Yes, they would be if their bases are 3 and 3. So we could just find the area of one of them and multiply it by 2. Yes. Good. So 1/2 base times height. What did you say the base was of the triangle? 3. What did you say the height was? 3. What's half of 3 times 3? 4.5. And then you could do that again for the other triangle, or as Thad said, it's got the same base and the same height. So we could just take that area of 4.5 and multiply it by 2 because we have 2 congruent triangles. So what's 4.5 times 2? 9. Did they give us any units on this? Nope. So it would just be area is equal to 9. Questions on the first one there? Okay, perimeter. How are we going to find the perimeter? We could do distance formula. If you don't like distance formula, you could do little Pythagorean theorems all the way around your shape by making little right triangles out of each diagonal side if you want to, or we can do distance formula and find the distance of these 2 sides and add them together. So let's do perimeter. I'm going to do it on the board and zoom in so you can see this a little better up here. It just depends on what you like better. I mean, to me, they're both about the same difficulty level. All right, so we want to find the perimeter. To find the perimeter, we're going to need to find this distance. And how many of those distances do we have? This distance is the same as this one, right? So we have 2 of those. And then we'll need to find this distance from G to H. And how many of those do we have? 2, because this side opposite, it's going to be the same. In a parallelogram, opposite sides are congruent. So let's start with GH. Let's find the distance from G to H. So remind me, what did they tell us on the notes? The coordinates were for G and H. Okay, so we're going to do distance formula from G to H. So what am I going to plug in for x2 minus x1? What am I going to write down here? Not -1, -4. -1 minus -4. Plugging into your distance formula, guys. Back at your distance formula if you've forgotten. It's x2 minus x1. So -1 minus -4. And then what do we do when we subtract them? Square them. And then we add. Okay, what are we going to write down for in the parentheses next? -4 minus -3. Just like we did, very good, squared, just like we did last semester. All right, so simplify. What is minus a negative? Addition. So it's -1 plus 4. 3, and we're going to square it. And then minus a negative is a plus, so it's -4 plus 3. -1, and we're going to square it. Be careful with your parentheses if you start using a calculator to do the math. 3 squared is 9. If you don't put parentheses around the -1, the calculator is going to tell you -1 squared is -1. -1 squared is not -1. What's -1 squared? +1. And so this becomes the square root of 10. And how many of those do we have? 2. Everybody with me that opposite sides are congruent in a parallelogram? So the perimeter is going to be 2 times the square root of 10 plus, and now we're going to need to find the distance from, what's the other side called? I don't care. Pick 2 points. H to E. All right, so now we're going to do H to E. So remind me, what are the coordinates for H and E again? For H?
Yes.
And E?
-1, -1.
All right, we're just getting those off our notes, right? Everybody's following with me? Okay, plug it in. What am I going to put inside my first set of parentheses? Say it again.
-4.
Thank you. And then in the next set of parentheses? All right. So -4 minus -1 squared, -3 minus -1 squared. Simplify. Minus a negative is a positive, so what's -4 plus 1? -3 squared plus -2 squared. All right, what's -3 squared? 9. Again, if you use your calculator, make sure you're putting parentheses around that, or it's going to tell you -9, which is wrong. What's -2 squared? 4, which means we have the square root of 13. If these would simplify, we would want to simplify them, but they don't simplify. And how many square roots of 13 will we have? 2, because opposite sides are congruent. So we have 2 square roots of 13. Okay, is everybody with me by doing that just times 2? Okay. And did the directions say to round in our directions? No. So we would just leave it as 2 square roots of 10 plus 2 square roots of 13 because it did not tell us to round. And you cannot add square roots unless these are the same. If you have a square root of 10 and a square root of 10, then you can add the numbers in front. Remember, you treat these like variables, just like an x and a y. So this is just like saying 2x plus 2y. Can you add 2x plus 2y? No. But if this was a square root of 10, then it would be like 2x plus 2x, which would be 4x. And so that would be 4 square roots of 10. You only add the numbers in front if you have the same square root. So just if you're ever unsure, think about your square roots as a variable. And what would you do if it was a variable? Then do the same thing if it's a square root. Okay? Any questions about that? Okay, on the next one, we're not going to work through the whole process, but I want to show you what's different about it. So last thing for today, look at the one on the back, because it's different. So everybody take a minute and graph it. It's the ABCD one. Again, be super careful when you're graphing it that you're plotting your points correctly or it messes your whole problem up. Okay, the same directions on this one, or actually the directions are different on this one. It just says find the area of the polygon. So if it did say to classify it, what do you think this is? Okay, I'm hearing rectangle from everybody. What would need to be true for us to, what would we need to check to make sure it's a rectangle? We need to make sure that we have right angles. So let's just do that real quick. Let's find the slope of 2 consecutive sides and make sure that they are opposite reciprocals. So from D to A, I would go up how far? Up 3 and go left 2. So the slope over here would be up 3, left 2, which is a -3/2. That's the same as down 3, right 2. Agreed? Okay, and then let's find the slope from A to B. How far do I go up from A to B? Up 3, right 6. And what is 3 over 6 reduced to? 1/2. Are those opposite reciprocals? No. So is it a rectangle? No. So be super careful that you don't look at it and assume it is, because it may look like a right angle, but it actually turns out to be an 89-degree angle, which means it's not a rectangle. Okay, no matter whether it's a rectangle or a parallelogram, would you agree once again that even if we found the distance for this base, we still don't know what the height would be going down to here perpendicular, right? And on the last problem, we said, well, we could divide it by drawing a diagonal and splitting it into two triangles, but that was vertical and that made it easy. Do you see how if we divide it here that that's diagonal and that still doesn't really help us? So sometimes you're not going to be able to divide it into two triangles. You're going to have to use this other technique. So this is what you can do as well. So I want you to take your pencil and I want you to draw a rectangle around this rectangle, connecting every vertex. So in other words, I want you to draw a rectangle that goes through every vertex. Look up here if you're not sure what I'm talking about and watch what I'm doing. But draw a rectangle that would go around this entire shape, but every vertex would touch it. Make sure you're doing this with me because you will have to do this on the homework and on the test. Because not every problem can you divide it into shapes. And not every problem do you have enough information to use the formula for it. So I want to find this shaded part, the part that we started with, right? Using what we just talked about in the last section. Do you see how we could find the area of the shaded portion? What could we do? Subtraction. What would we find the areas of? Okay, so we need to find the area of the great big rectangle and then subtract away the area of all the little triangles. Okay, so let's do that. Let's start with the area of this great big rectangle. How do I find the area of a rectangle? Base times height. You guys talk to me, help me out. What's the base length? 8. What's the height? Everybody with Michael? Tate? Everybody's good? 8 times 6 is? 48. Thank you. All right, that's the area of the rectangle. Now we need to find the area of all the triangles. How many triangles do we have? 4 of them. So let's start with, I'm going to number them 1, 2, 3, 4, just so you can follow which one I'm talking about. Let's find the area of triangle number 1. So area of triangle number 1. What is the formula for area of a triangle? 1/2 base times height. Looking at this triangle, what would we call the length of the base? 6. What's the height? 3. What's half of 6 times 3? 9. Okay, so we found the area of one triangle. Now let's find the area of triangle 2. Same formula, 1/2 base times height. What's the base of triangle 2? 2. What's the height of triangle 2? Careful. It's 3, right? If we go all the way down to this vertex, be very careful on your graph. That's a height of 3 and a base of 2. So we're going to do 1/2 of 2 times 3. What's half of 2 times 3? 3. Okay, so we have 2 of our triangles. Let's go to triangle number 3. What's the base of triangle number 3? 6. What's the height of triangle 3? 3. So that's going to be exactly the same as triangle 1, right? Half of 6 times 3. So we know that the area of triangle number 3 is just what? 9. So everybody following me there had the same dimension, so it's going to have the same area. Okay, let's go to triangle 4. What's the base of triangle 4? 2. What's the height? 3, which is the same dimensions as triangle number 2. So the area of triangle 4 is going to be the same as the area of triangle 2, which was 3. Okay, we're going to do what with all those triangles? Add them all together. What's 9 plus 9 plus 3 plus 3? What is it? 24, correct. 18, 24. So the area of all the triangles would be 24. What are we going to do with the area of the triangles? Subtract it from the area of the rectangle. So the area of the shaded part that we wanted would be 48 minus 24, which is how much? 24. So basically what I wanted you to see today is you can take a shape and you can divide it into other shapes. Add them all together. You can take a shape and subtract away a part in the middle that you don't want. You can take a shape on a graph and divide it into shapes, or you can surround it by a rectangle and subtract away the parts you don't want. Estimate only if it's on a grid and it says estimate, okay? Any questions on today's lesson? All right, I expect you to start your homework. You have 20 minutes in class and the entire time Wednesday in class. So no excuses. You should not be going home with homework over spring break. This should be turned in on Wednesday. You will need graph paper for the homework. I do not need that back. Make sure you grab some graph paper and go ahead and get started. Let me know if you need my help. You may listen to music as long as you're working. Okay, thanks.